Hi, Profs. My name is Henley, and here are my members Jonathan, Edley, Jin-Yong, Yihao, and Hongshen. So we are Group P1-9, and we'll be presenting about our IoT and DA2 predictive maintenance of green energy project. So this is the scope of our presentation. So LNG is actually transported throughout the pipeline. So throughout the pipelines, there's actually ultrasonic flow meters, USM for short, to collect statistical data to analyze the fluid transmission and properties of the LNG through the pipeline. So the problem statement is that the data collected needs to be provides health status and smoothness of the fluid transmission before being sent for health predictive maintenance of the entire green energy transportation. So for this project, we actually have access to 3 data sets, meters B, C, and D. So before anything, we need to do data pre-processing. So the first step is to do a data reduction. So by adding the averages for the following columns as shown below, we actually can reduce the data by collating the averages and removing the individual columns of each individual paths for the respective meters as shown below. So the next step will be the feature importance. So we actually utilize the low variance feature removal and the univariate feature selection. So from there, we actually managed to attain the most important to least important feature importance with a variance threshold of 0.8. So you can see that symmetry and crossflow did not meet the requirements, so therefore they were removed from the data set. So from there, for the feature extraction, we actually use the principal component analysis. So for meters D and D, we actually the variance ratio of using 2 principal components was actually sufficient. However, for meters C, we needed 3 principal components were required to represent the data. So for the next step is to identify the relationship between data sets. So you can see that meters C and D actually have correlation between each other as shown, perfect correlation between as shown in the data below where there is perfect correlation. So however, we can actually see that when we compare with meter B, there is almost no relation between C and D when compared with meter B. So we can identify that there is some relationship between the pipelines when the LNG is flowing through for meters C and D. So now I'll pass on to Jonathan to talk more about the data mining.
Okay, thanks, Andy. So from the principal components, they will undergo various classifiers like KNN and IPA with the different classifier parameters applied. Next. So this will allow us to find the parameters that give the highest accuracy for each of the classifier. Next. So all this data were later averaged and compared with each other to find the highest classifier with the highest accuracy, so which is AAN in this case. However, we cannot solely base on this accuracy to choose the final classifier to be used. Thus, visual inspections are required. Next. So from the visual comparisons, we use the 2 highest classifiers, which are KNN and ANN. So as you can see on the images above, for meter B, both for ANN, it has a much better clustering and separations between the regions as compared to KNN for meter B. However, for meter D, both show some random clustering for both meter D and B. So overall, with the accuracy and clustering, ANN was chosen to be our final classifier. Next. Yeah. So for ANN with a hidden layer of 61, it gives us the highest accuracy. However, for the visual inspection, it shows that the data is getting overfitted. Thus, we reduce the number of layers to 60, which gives us a lot better clustering and separations between the different classes. Yeah, next. So for the final accuracy, it comes up to 86% with ANN with 60 layers. And also some further studies were done using the classification reports and confusion matrix. Next. So from these studies, we can see that class 3 of meter D has the most wrong predictions. Yeah, next. So overall for the results, ANN is very accurate for all 3 meters. Only class 3 of meter D comes with some wrong predictions. This is because these data sets are extremely compacted. So it leads to difficulties with the classification regions. So more methods like scaling or normalizing can be studied to further separate the class data. Also for ANN, it's very good for this data set as it's robust to noise and it's good against non-linear data sets. However, for ANN, it's computational intensive and is prone to overfitting as well. So it's critical for us to choose a suitable hidden layer size. And also we must use PCA methods to ensure minimum dimensions to reduce the computational requirements. And even though ANN training is long, the testing is relatively fast. Thus, ANN is suitable to give responsive and accurate predictions of the health states of the LNG pipelines. Yeah. So now I hand over to Yihao to discuss on the big data.
Okay, so for the big data, we will start off with the system architecture. So the system architecture is a software structure designed to demonstrate the workflow of the operation. So the principle of the architecture will be obtaining the measured data, transferring it to the storage, and sending it for batch processing. And it will be stored according to the batch of the data. So once the batch processing is done, the data will be sent for analysis and finally presenting the result of the data. Next. So for the liquefied natural gas process, it will be first obtain the measured data through the hardware components, the ultrasonic flow meters, where it will record the flow of the liquefied natural gas through the pipelines. And next. And once the measured data is recorded, it will be sent to the software components, where it will send the data to the for processing for the batch categorization, and after which it will be transferred to either the local storage for real-time analytics or the online server storage for further processing or analytics. And after the processing and analytics, the operation data can be displayed on a real-time view for the operators, or it will be transferred to the data consumption process for visualization implementation. Yeah, so finally, with the aid of the visualization of the data, the operator will be able to present the report of the operation and determine whether it fulfills the requirements. Next, I'll pass to Eddie. Yeah.
So there are 3 common types of data storage, of which we'll focus on cloud and server as they are most relevant for this application. Next. Cloud storage works by receiving and storing the user's file on remote services that can be connected to remotely as long as they have internet access and permission to access the data. Server-based storages are used to store, access, manage, and secure digital data files and services on-site that can be accessed over a shared network or the internet. Businesses should look towards having a mixture of cloud storage and server-based storage when handling their data. Cloud storage can be used for archiving large sets of data and for processor-intensive tasks, while server-based storage can be used for handling sensitive information or critical tasks. Next. So now we'll be covering the methods of handling the data. Services related to cloud computing and remote access can be described as anything as a service. And we'll be focusing on IaaS and PaaS, infrastructure as a service and platform as a service. Next. IaaS has control over the operating systems and underlying applications, allowing company to build high security. And it can also be used to archive data collected, which can be later used for machine learning to better refine predictive models for monitoring the applications. PaaS offers frameworks and software and tools that allow users to develop applications without having to worry about infrastructure management. Now I'll pass my time on to Jin Yong.
Message processing is how the raw data flows from the IoT device, gets processed and is delivered to the consumer. For message processing, 3 factors need to be considered. Firstly, simplifying the software product. With an array of complex data, to make matters worse is by adding a sophisticated code to process the data. The code needs to be kept simple and straightforward and can be modified and supported cheaply. Secondly, fault tolerance. Whenever the service provider is not available or there is a processing error, the database needs to stop and prevent any data from being lost. The affected message needs to be saved in a message queue and be processed right after the issue is rectified. Thirdly, performance. The architecture needs to be optimized after the first round of testing to ensure it achieves the intended purpose. Next. As a business user, the pattern that can be adopted for data ingestion and visualization of real telemetry data sent from the ultrasonic flow meters is via AWS IoT Core, using AWS Lambda, Amazon DynamoDB, AWS AppSync, and a customized dashboard. The AWS IoT Core will send an MQTT message to an AWS Lambda function, which will be formatted and executes an AWS AppSync GraphQL mutation. This mutation call will save the data in an Amazon DynamoDB table and reflect the data in real time to the custom dashboard. The customized dashboard is subscribed to the AWS AppSync to reflect real-time data. This pattern allows for the data to be delivered to the user whenever there is any change via a customized real-time dashboard. It also allows for real-time monitoring via mobile application. Hongsheng will now be talking about the data visualization.
Okay. So now we're talking about data visualization and why is it so important. So as data visualization is very important because it has the ability to condense a huge amount of information and then present it to a user in a clear and concise manner if done properly. So another advantage of data visualization is that through data visual, the user is able to gain new insights or patterns, which can be a priceless information that allow the industry to develop new opportunity for business. And finally, users with no knowledge of mathematics or computer science can also easily integrate the data visual. Next. So one of the challenges faced by industry currently is the ability to integrate its own data. So one of the most effective way to deal with that is by designing an IoT dashboard. So some of the key advantages for using an IoT dashboard is due to the responsive design. It is easily viewable from a smartphone, laptop, or tablet, and as well as it is configurable to be updated in real time. Next. So in conclusion, big data architect is very useful is because it is designed to deal with the processing and analysis of data that is might be too large or too complex for traditional database system. Using this architect is able to currently identify the current threat based on the data and is able to predict the future outcome. It also allows the user to interpret the data without any in-depth knowledge through the dashboard. And finally, through configuration, you can configure the dashboard to be updated in real time. So these are some of the key features. So with that, I would like to end the presentation. Thank you very much.